in this lesson, what we're going to be doing is taking some animation that we did in a camera move from Cinema 4D on this shoe model, the shoe scan that we have. And then we're going to be importing it into Houdini and then doing a pyrosim inside of the shoe. And the pyrosim is going to drive all these different things that we're seeing on the screen here. So we're going to get a this sort of growth volume, the kind of surface that we're seeing. We're going to get these sort of trails of particles that are being pushed around by the volume as well. And we're going to do it all you know, just kind of using different volumetric simulation techniques. So we've got some, you know, your basic pyro smoke sim that we're going to turn into a mesh. And then we're going to use that pyrosim's velocity field to drive a new particle system to create this really abstract kind of flowery, feathery growth effect. So I think it's a pretty fun one, and I hope you enjoy it. So over here in Cinema, I've got this shoe scan that we've used before. You can see I've brought it in here. I just have my project directory with that geo stored in here and a couple of start projects. We're going to be starting with this lesson 10B advection 01 start. So this project, basically what I've done is I've just added a little bit of animation to the shoe, so it looks like it's kind of doing, you know, it's like in the process of, you know, bouncing off the toe. And then I've just added a little camera animation to go along with that. Like so. So let's play that back. So that's what we're working with here, and we're going to make this shot look a lot cooler. We don't want to actually see all this gnarled up shoe scan geometry. None of that's interesting for our purposes. We just want to use this as a collider and emit some smoke and particles in it to create kind of a cool shoe building on effect. So let's export this so that we can use it in Houdini. Only things I need, I don't really need the plane, although I guess I could export that if I wanted to, but I'm just going to select the camera and the shoe. And then I'm going to go over to File, Export Alembic. And I'm just going to create a new folder in my project directory here called ABC2H. Because later on we're going to have an ABC2C4D folder where we bring alembics back in. So let's do the ABC to H folder, and I'll just name this based off of what the project is. So lesson 10B advection 01 start.abc. Sounds good. And here I want to make sure my start and end frame are set to the bounds of the scene. Centimeters is good. Selection only. Make sure that's checked. Global coordinates checked. And cameras are checked. Because we'll use all that stuff on the Houdini side. So let's click OK. Just going to think about it for a second. And now over here, we've got that Alembic file. Let's see, wow, it's pretty big because it looks like it had to bake out that deformation of all these points, but no big deal. So let's go back over to Houdini and try and get this thing going. So to get the Alembic in, we're going to need to throw down a geo, and then let's just dive inside and create an Alembic. And I'm in wireframe mode. I'm just going to hit the W key to go back to regular mode. And I'm going to select from my ABC2H folder that Alembic file. And by default, it comes in gigantic. So I'm going to scale that down. Let's just throw down a transform. And because everything in Cinema is in terms of centimeters and in Houdini the unit is meters, we just need to divide by or multiply by a factor of 1/100th or 0.01. So now if I hit spacebar F to frame up that shoe, you can see that we're in the right space. The shoe is pretty much sitting on the ground the way we had it. So that's good. Next thing, just for reference, I want to get my camera in here. And so I don't do the camera the same way as I do the actual geo, even though the camera is stored in this file. When you use the Alembic import, it doesn't bring in the camera. So let's go get the camera, doing it the other way. So I'll go File, Import Alembic Scene, and then I'm just going to go and select that same Alembic file, hit Accept and Import. And then you can see if it throws me inside my network here, but if I hop back out to the object level, you can see that it's created this new lesson 10B advection start folder that has the camera and the shoe in it. I'm just going to disable the shoe because I don't really need that. But I do want the camera. So now if I go up here to where I can select my camera and say look through that camera, of course this camera is gigantic as well. So it's moving through space, and you can see my little tiny shoe down there. We need to get that we need to get this whole thing scaled down to size as well. So the way we do that is we parent it to a null in world space and just scale this null down the same way we scaled the geo down. So now we're pretty much 1-to-1. We've got our camera move in here. So the next thing I want to do right here is my bounds of my scene by default are going all the way out to frame 240. I'm just going to set this down to 72. So now when we scrub the timeline, we're right there in the frame range that we're interested in. I'm also going to turn on the real-time toggle so that it isn't playing back faster than it needs to be. Awesome. So what we want to do is fill this shoe with smoke. So to get started with that, we're going to need to create an emitter. So I'm going to go and throw down another geo. Actually, I'll name this one. This is going to be the shoe right here. Shoe animation. And we'll create an emitter that goes inside the shoe. So let's create another geo. And inside of here, we'll call this the emitter. And then we'll jump inside and create a sphere. And the sphere is gigantic as well. Let's just bring that down to a value of like 0.02. The next thing I like to do is convert it into a polygon. So I'm just going to do that, and I'll crank the frequency up to something like 4, just so that it looks spherical, but it's got points there so that we can, you'll see in a second. So the next thing is let's bring this emitter and put it inside of our shoe. So I'm going to pull up I'm going to grab this white square in the corner and select my 4 views. And then I'll grab the sphere, select my manipulator, and then we can bring it into position. So I'll position it in the top view so that it's sort of inside the heel here. And then in the side view, I'll just bring it up so that it's right inside that ankle / heel. No, more like the heel area. Yeah. Okay, cool. So I'm going to switch back to the single view. And so cool. This is a good position for our emitter. But the issue, and this is an issue that comes up when you're doing like real, in production scenarios, you'll have situations where you've got animated geometry and you want your emitter to stay with it. We could just keyframe this emitter to stick along with the shoe, but that wouldn't be very procedural, would it? So what we're going to do is just point deform this sphere to stay in place along with the shoe. So a lot of times I'll do this. I'll take the incoming geo and use it as a deformer to make things kind of stick to it when I need them to. So let's object merge in our shoe. So here I'll bring in an object merge and then I can go grab my shoe. But let's see. In my shoe animation, I'm now realizing that I have not converted it into polys yet. So let's just cancel out of this real quick. I'm just going to hop out and go into the shoe animation. Here, if I middle mouse click on this transform, you can see we have 1 point primitive vertice. It's one packed alembic. You can unpack the alembic doing certain things on the alembic node, but I like to actually do it just by throwing down a convert. And then when we wire this in, you can see that we actually get polys showing up that we can select. So like that. We actually need all these vertices and stuff in order to do our any sort of point deformation or really anything geometry based. We need to have actual geo. So if I middle mouse click now, you can see we have 140,000 points and so on and so forth. So now that we have this, I'll throw it on a null so that we can easily access our shoe from the other network. So let's just name this shoe in all caps like that. And then I'll go back into the emitter section and we can now do our point deformation. I'll bring this in. Let's select our shoe that we just created, that null under shoe animation, hit accept, and then we'll throw down a point deform. One of my favorite nodes, so handy when working with geo from another application. So in the first input, we need the mesh we want to deform, and that would be our emitter. We want our emitter to deform and track along with our shoe. So we're going to wire that into the first one. The second one, we require a rest point lattice, and then the third one, we require a deformed point lattice. So the rest point lattice, well, we have the first frame of this. We just want to lock down the first frame of this animation and let it stay as the rest position, and then it will compare where the moving geometry is going to. So we can do that with a time shift. Let's throw a time shift in here, and by default, if I wire this into the object merge, the time shift does nothing. It simply just evaluates to whatever frame we're on up here. So if I just delete channels on this and set that frame to 1, now when I scrub the timeline and say hide other objects, you can see that our shoe is staying locked. So, but our actual geo that we're merging up here is still animating. So I just need to wire these two inputs in. This is our rest geometry, the one that's staying still, and then our deform geometry is the one that we are just mapping in here. So now if I highlight the point deform and maybe template the object merge, you can see that our sphere is now tracking along perfectly with the shoe. Sweet. So now what we could do is set up our emission. So I'm going to give this a null, and we'll call this the base emitter, just to keep it organized. And then what we'll do is create a pyro sim. So I like to start when I'm just doing something like filling an object with smoke. I feel that under the pyro effects tab up here, I think that billowy smoke is a really good starting point. So let's just select our emitter and then choose billowy smoke. It's going to think about it for a second, and then it creates this auto dot network for us. And in our emitter, it adds this these nodes for creating density and temperature attributes, like we saw in the last lesson. Scatters some points, and then it adds noise to those density and temperature attributes, and then rasterizes that volume into something that is able to be emitted into our auto dot network right here in our volume source. So if I click play, you can see that we get this sort of this kind of violent smoke kind of pouring out of this geo. Now our bounding box is not in the correct position, and it's really difficult to see what's going on with this shading. So what I like to do is I kind of come off to the left over here with my camera, and then I'm just going to add a light to the scene just because it helps the viewport look a little bit nicer when we're doing stuff with volumes. So under lights and cameras, I'll just control click an area light, which places a light basically wherever my camera is positioned in the viewport. And then as long as this lock isn't checked, I can just navigate away from that, and I have some shading in my scene like that. Let's just jump back into the auto dot network. It's looking pretty thick, pretty dense. I'm just gonna modify the shader a little bit. So it's just a visualizer. This doesn't have really anything to do with our final product, but it's good to kind of just look at these things to make it easy for yourself to visualize what's going on. So by default, you know, when we're doing billowy smoke, it's considering things like a smokestack or some gigantic sim, and we're actually inside of a shoe. We're in less than a 1 meter scale. So that's why this smoke is super violent at this stage, is because its temperature is pretty high, and that creates sort of kind of violent behavior inside of the sim. But also it's trying to guess its best way to make it so that this is visible at the scale that we're at, and density scale of 100 is just too high. So maybe I'll bring that to something like 10, so it looks a little bit foggier, and maybe a shadow scale is a little high too. You can see that that's really crushing out that shadowed area, and I really just want to see where this density is. Maybe I could bring the maximum level up a little bit. The shadow scale, maybe I'll bring a little bit of shadow back, maybe a little bit more density. Maybe we'll do something like a density scale of 20, and yeah, a shadow scale of 4, let's say. That's looking pretty good. So, I mean, it's not looking great. Honestly, this is super low res at this point, but so let's fix that as well. What I like to do when I'm working with Pyro is I like to work, instead of choosing like a world space division size, I like to do a max axis and then just set the resolution here. So for like kind of just the first few iterations, I like working with a uniform division of 150. So if we go back to frame 0 and click play, you can see that that looks a little bit nicer for us. Still not super it's not like, it's not the fastest thing in the world, but it's also not the slowest either. So it's just good for kind of getting some results. Okay, now the other problem that we're having is that if we were to show ghost other objects, you can see that it isn't really fitting into our shoe here. We need to actually have this voxel grid that we're going to be simulating within to to fit within the boundaries of our shoe. And so let's just set up a nice little procedural way of this for this voxel grid to set its size based off of the size of the shoe. I'm going to get this camera out of the way by turning off that display flag. It's a little distracting. Okay, so I'm going to go into the shoe animation and we'll create some bounds. If we look at what, I'm going to just hide other objects for a second. If we look at what our shoe is doing, it is basically just doing kind of a linear motion between the first and last frame. And we really, we can use this to our advantage. We could actually just set a bounding box based off of these two positions, the last position and the first position. We know that if we set a bounding box based off of those two conditions, that would more or less encompass all of our sim. Now, if it was doing all sorts of crazy stuff in between, like if it was moving off to the side or doing any crazy rotation, we might need to maybe take a couple more samples. But for our case, the first and last are going to be fine. So the way we're going to do this is we're going to select the first frame and the last frame using another time shift, just like we did for the point deformer in the emitter network. So let's go and throw down a time shift, and I'm going to wire that in here, and we're going to just delete the channels so this stays locked on frame 1. And then we're going to, I'm just going to alt drag this off to the side, and we're going to set this to frame 72. That's the maximum of our animation here. So between these two poses of the shoe are more or less going to encompass everything, every space in which our simulation is going to occur in this scene. So we can actually create our bounding box dynamically by merging these two together like this with a merge node, and then we're going to use the bound node. Cool little node, basically takes whatever the input is and creates a bounding box out of it. So now that we have this bounding box based off of our first two, out of these two, and you can actually, you can see this here. So if I were to sort of disable this merge, but template the bounding box, if I were to just simply take the bounds of the first shoe, you can see that we would get some stuff that ends up leaking out at the top. That's not good. So so we don't clip it, we actually merge them together and we get this bounding box that sort of handles everything. A cool thing with the bounding box, we can actually give it a little bit of padding. Like here, it looked like something was kind of popping through. If I were to more or less merge these one more time. So I'm going to just option drag that merge down. And instead of merging those two, I'm just going to merge the merge with the bound and see if anything is popping through. And it's looking like it fully enclosed our shoe. So that's good. I'm going to get rid of that now. And if we wanted to, if something weird was happening, we could add some bounding here. You can see that, or some padding here. And you can see that you can add lower and upper padding if you want to increase the size of that bounding box. For our purposes, I'm just going to Control Shift click both of the, Control Shift. Is it, let's say revert to defaults, Control middle mouse button. So I'm going to hit Control middle mouse, click both of these to set them back to 0. And for this bound, I'm just going to throw down a null afterwards so we can reference it and use the bounding box and centroid functions to set our grid. So we'll say bounds. So now we just need to hop back over to our Pyro sim and use these expressions to get the bounding box to match. So let's go into the auto dot network and I'm going to select the Pyro object, make sure I'm on frame 1 when I do this. And we're going to do the size first. So for the size, we're going to use the bounding box function. So type in bbox and open parentheses. You can see it gives us a little helper here. And we're going to want to set up a string to the path a string that points to the path of that bounding object, and then we're going to want to use the dx size for this x parameter here. So it gives you a bunch of little options you can put in here to get certain values, and the one we want is d_x size. So I'm going to open quote, and .. will bring us out of this node and able to reference some other node within this network. Doing it again, .. brings us actually out to the object level and allows us to select a different network here. What we want is to go into the shoe animation, so I'm going to click that one. You can see that bounds pops up because it's alphabetically the first in the list because I capitalized it. But if it's not showing up, you can start typing in whatever you name that null, bounds, for example, and then hit tab and then close quote. Then we put in a comma for the next parameter and put in dx size like that, and then close parentheses, and it adjusts the size of this bounding box accordingly. Just need to copy this into the other fields, and so I'm going to hit Control A, Control C to copy that, hit Tab to go to the next field, and Control V to paste it. And instead of X size, I want the Y size. And then again over here in the Z section, I want to use the Z size. Now its center is off from the original bounding box, so I'm going to use the centroid function down here. But I'm also going to want to reference this same string that we used up here. So I'm just going to copy that string to that bounding object and use it in the centroid function. So I'm going to start typing centroid, and here again it gives us this tip. We want to use these d_x, y, and z dimensions to grab our centroid. So I'm going to paste in that path to the bounds and then put in a dx. And then I'm going to hit Control A, Control C, Tab, Control V, back, delete that, turn it into Y, Control V again, and turn it into a Z. So you just kind of copy all those into each of the X, Y, and Z fields and adjust that last parameter accordingly. So now we can see that we've properly set up our bounding box to deal with our smoke colliding with our shoe, but we don't have any smoke collisions with our shoe yet. So let's set that up. The way I'm going to do it is slightly different. You might think that you would take, I'm going to go back to the shoe animation and actually highlight the shoe so we can see it. You would think that we'd want to actually just grab our shoe and go up to our collisions tab up here and choose a deforming object. But what I found is that it actually does this extra calculation in the PyroSim to based off of this. It does it based off of the default shelf setup for collision with the deforming object in a PyroSim. In my instance, it was creating an extra long calculation buried deep inside the PyroSolver, and rather than solve it or try and fix that, I ended up going with an alternate method for creating collision, which is actually sourcing it in as another volume. So we're going to handle it that way because we want to keep this thing performing as fast as possible. Because no one wants to wait extra long for a sim if they don't have to, especially when it's doing something as simple as collision. You'd think collision's pretty simple, but it's honestly one of the more complicated parts about doing sims in general, I find. Just because it can be super finicky. So let's go and create a volume collider that we can source into our sim. So we're going to do that creating a VDB. So I'm going to go here. I'm going to throw down a VDB from polygons and just wire that right here. You can see that it's super low res. So let's bring the voxel size down to 0.0025, something like that. And we can see the shape of our shoe looks pretty good there. And it plays back reasonably well. So now that we have this VDB, what we're going to want to do is just throw down a null. And I'm going to call this the VDB collider. VDB collider. We'll capitalize that R because that's bothering me. So we've got our VDB collider here. Now we can source this in if we go back over to our sim. And at this point, I'm actually going to just switch to a quad view. So I'm going to alt click on this middle bar right here so that it splits left, right. And then I'm going to split this pane top bottom and split this pane top bottom. Then down here, I'm going to right click and select a network view. And up here, I'm going to right click and select a parameter view. I'm going to pin these first two to the number 1 and pin these second two to the number 2. Like that. So now we have our 2 views, and we went through that setup before, but it's fast enough to just do it. Figure I'll show you on the fly. Cool. So in our auto dot network, if I go back to frame 0, we're going to throw down our source volume, and then we're going to source in our collision. So let's throw down a volume source and kind of look at what this volume source is looking for from us. If I just wire this in here, you can see that if I go up here, it says initialize. By default, it's initialized as smoke source, or to source smoke, I should say. And we can actually set different things here, like, expanding, pumping. Basically, this is making smoke disappear, expand away, or whatever. But we can select collision option here. So when we select collision, you see that we get all these different, it creates these 2 different default fields for us. One of them is the collision velocity, and then there's the collision itself. Over here on our VDB from polygons, if I middle mouse, you see all we have is a surface. And that surface we could certainly map in to be our collider. So I'll just do that right now. We'll call this surface. Likewise, I could just rename this VDB from polygons to be collision. That would work too. Just as long as whatever the name is that is coming out of this VDB matches what's coming in from the source volume here, it should all work fine. The other thing I need, though, is this velocity, and we don't have velocity here. In fact, we don't even have velocity attribute on our shoe. So let's create that for the purposes of our collision. I'm just going to throw down a trail. So the trail node, just wire that in before the VDB from polygons. The trail node has an option on it to compute velocity. And now you can see that we have a velocity vector. But when we go down here, that still doesn't mean that we have a velocity surface yet. We actually have to tell the VDB from polygons to look that surface attribute up using this field right here. So I'm going to click the plus icon. It adds the ability to select a new attribute. And you can see that this point.v attribute is here. And the VDB name that we want to create, well, we can create the V volume. It's looking for a source volume called V here, so let's just name that one V. And then we can choose displacement, velocity, and acceleration as the vector type because it is a velocity vector. So now we've got these 2 surface and V volumes that are being sourced into our collider right here, except we don't actually have a SOP path defined yet on the source. So I'm just going to drag our VDB collider right up into that SOP path, and we should be good to go. So if I click play, this collision may look like it's doing all right, but it's not. If we were to let this play out, it isn't quite doing what we want it to do. It's not terribly obvious in this example. I wish it were a little bit more obvious, but really what's going on is that when we source in a volume, as our collider, it's using a sign distance field, which basically has a negative value on the inside and a positive value on the outside. And it's using that negative positive value to determine whether something is inside or outside of a collider. And because we actually want to be inside the thing we are colliding with, we're going to need to just change the scale to be the opposite of whatever it is right now. So if I switch this scale to +1, we'll get better looking collisions inside of our shoe. So let's just click play. And now, whether that was terribly obvious that it did anything or not, you can see more of the shape of the heel and the shoe in general, I think, at this point. But basically, we've just flipped the collider inside out. So literally all the space that isn't the shoe is going to be the colliding surface all around here. And then that's going to be sort of holding the shoe in and allowing it to move throughout the interior of the shoe. The next thing that I want to do is address what's going on with the resize container. The resize container is here to actually make things run a little bit faster, and it isn't really doing that great of a job of resizing. We want it to sort of crop in on the actual region that is being of density that we are calculating over here. So let's just tweak some parameters on the resize container to get it to do that. So I'm going to bring the subtract threshold down a little bit. That gives it a little bit more leeway in terms of computing where it needs to go. But additionally, I also bring the field cutoff down. The field cutoff is basically how low the density can get before it decides it wants to not consider it. And a lower value means that it's going to consider lower densities a part of the simulation and leave them in the simulation. The other thing I want to do to kind of speed things up is I'm going to go to the Pyro Solver, and on the Advanced tab, I'm going to tick Use OpenCL. Now, if we end up using a super high-res sim and we can run out of VRAM pretty quick depending on like what the specs of your graphics card are. I'm using just a 1080 Ti, so I've got about like 11 gigs in mine. I find that I can run out of that RAM. I've maxed that out pretty quickly in a lot of instances. So sometimes I have to turn this off, but it actually makes the sim run like twice as fast sometimes. So I'm going to turn on Use OpenCL, and let's just preview what we got. I'm going to hit spacebar 4 so that I can get that side view. And let's just watch and see what our resize container is doing to, kind of track our density simulation along here. So you can see it's resizing and following along with the sim, and that's all looking good. But it doesn't look like my sim is actually even capable of filling all the way down to the bottom of the shoe right now. And I think that part of that has to do with the fact that on the Pyro Solver, we have dissipation going on. So this dissipation is just causing smoke to like sort of, just fizzle out. And I actually want that smoke to remain thick throughout the entire simulation. So I'm going to just disable dissipation. And I'll just play that back one more time. So we can see that smoke is remaining thick down here, but we're running into a new issue. This bottom of the shoe goes all the way down to this bottom grid line right here, and now this resize field is not properly cutting. It's starting to cut off our simulation. I have kind of a difficult time dealing with these resize containers sometimes, so I gotta kind of improvise in terms of getting it to do what I want it to do sometimes. So what I'll do here is I'm actually going to go over to the max bounds section here, and I'm going to untick clamp to maximum. The clamp to maximum in general will, if you untick this, it'll allow this container to continue resizing and resizing up to, until your computer runs out of memory. If the smoke sim goes that far, based off of like how much the smoke is expanding, but because we know we're confining our smoke in this area, that should hold it in place for us. So I'm going to untick clamp to maximum. Let's go back to frame 0 and click play. You can see now here it is doing its job to keep that simulation framed up nicely. So that's working for us. That's great. I'm seeing it looks like some little extra puffs are almost like escaping into our collision object. I'm not going to worry about that right now. I don't think it'll really show up in the end. But if it does, we can deal with that. I'm not sure if that's an OpenCL thing. It might be, but we'll just go with this for right now. The next thing I want to do is check. Let's just check what the kind of framing is looking like. So if I go back to our camera, I just want to kind of see how this is playing out through our sim. So one thing I'm noticing is that this is pretty low in the frame for the beginning of my animation, and it also is like emitting immediately. There's actually density here on frame 0. I want that density to sort of start to appear instead of it already being there. So what I'm going to do is I'm going to just kind of mess around with the source a little bit. Let's go over here back to our emitter. And I think that because we're adding this noise to our simulation, let's go, and I'm going to just disable this template flag up here. Because we're adding noise to our simulation, I want to just like, it's additive, but what I want to do is actually have it subtract from our simulation for the first couple frames, or, make the noise not as prominent in our scene. So what I can do is actually remap this minimum and maximum value. And if I bring this maximum value down to -1.2, it's just basically going to be subtracting 1.2 from our entire simulation in terms of density and temperature. And then we can just ramp this maximum value back on over the next couple frames. So I'm going to just turn off the brain real quick by hitting that guy down there. And then Let's go out to frame 6, and I'll hold down Alt and click this maximum here to set a key. Then I'll go back to frame 1 and set the maximum to -1.2 so that it is just going to kind of ramp on over that short period of time. And I'm going to go back to frame 0, turn the brain back on, and click play. I need to be in my pyrosim, so I'm just going to select a node over here in my pyrosim so that it switches my view, and click play. And I can see that now my resize container is not tracking my sim anymore. That's because it doesn't have any density to work with on the first frame. So what I can do is actually delay the number of frames that it takes for the resizing to kick in. So maybe I'll try and increase this to 1 frame. Then if I click play, you can see that it waits just a second before doing its resizing operation, and then it starts to do it like so. So other things I'm noticing as I'm looking at this sim, just to do a little bit of art directing here, it looks like this smoke is super violent. It's very turbulent. That being like a lot of noise is being applied, basically because the temperature is so violent and hot air rises. That's where all our velocity is coming from. We're not actually adding any velocity in our sourcing, but this temperature is doing sort of what all this crazy noise that we're seeing here. I'm going to just try dialing this down, maybe to like a factor of 0.05, and then see what we get. Because in the end, I want something just a little bit more mellow than what we have. And I think that this might be working a little bit better. You can see that it's kind of creating some nice, kind of bulbish looking things. So when we go and mesh this later, it should look pretty cool as it continues to fill out our shoe towards the end of the simulation. Now, I'm not noticing this issue really with my project right now, but I did have this problem sort of before. And that was that it couldn't actually get... the smoke was having a hard time filling all the way down to the toe, and you can kind of see it actually isn't really getting there. There's this giant gap in the middle of our toe right here. So what I want to do is actually mess around with the buoyancy force to get it to help fill down a little bit better. Because hot air rises and our buoyancy lift is set in the positive Y direction, just like you would expect in real life, we can actually just switch this and have it so that hot air falls instead. So it's sinking. And maybe if we needed to, we could actually force that a little bit harder by cranking up this buoyancy lift. But let's see what we got and run this one more time. And every time I say one more time, I really mean let's run this like 10 more times, just because sims take a few times to get them right. Yeah, I'm seeing that by frame 70, I'm not really getting that filling down as much, so I think I might just push this buoyancy lift a little bit harder. Let's push it to, let's try a value of 1 first off and see what that gets us. You know what else I'm noticing is that maybe it's actually cooling off too quickly. So maybe I'll just reduce this cooling rate a little bit as well. So let's take the cooling rate down to, let's just cut it in half. So I'm going to do 0.3. That cooling rate basically is going to keep the temperature hotter. So it's going to want to rise. It's going to want to continue to rise or fall into our buoyancy just for a little bit longer. Let's go back to frame 0 and click play. That's getting there. We still have sort of a gap here in our toe. So let's just increase the buoyancy lift by to a value of 2. Still having an issue actually filling down to the bottom of the shoe. So I'm going to, let's try some other stuff. Let's try decreasing the temperature diffusion. I'm going to maybe cut this down. Well, to make sure the buoyancy lift is actually doing something, I'm going to try an extreme value like 10. And that certainly appears to have helped in this situation, but it looks like it's not fully it's not fully taking up the space on the top of the shoe anymore. because of that buoyancy lift. So maybe what I'll do is let's just bring the buoyancy lift back down to 5, and then what I'm going to do is just cut the temperature diffusion in half. Let's put it down to 0.003. And that is looking like it's filling our shoe in nicely. It doesn't need to fill it perfectly, but just little options that you can explore if you're not getting the results that you like. Cool. Let's just look at it through our camera again, see what we got. Yeah, that smoke sort of just kind of travels down nicely along with the camera as well. And we may need to adjust our camera later on, and that's totally fine. I think that one thing that's kind of bothering me is sort of the position of the emitter in the first frame as it first starts to occur. It's a little bit low in the frame. I want to see if maybe I can adjust that. So I'm going to go back over here to the emitter. And let's just take a look at where that sphere is located in reference to our shoe itself. Now, if I go out and I'm going to just kind of see if I can position this sphere a little bit higher in the shot. It looks like I've got some room here to bring it up higher inside the shoe. So I'm going to just do that. Let's just grab the manipulator and grab our sphere. And I'm just going to switch to the front view. Also, what I'm going to do is bring up a second view so I can reference what I'm doing in the other shot. So from the other camera angle. So I'm going to go up here and say split pane top bottom, and I'm just going to select my camera view down here. Let's hit the D key and choose to change the background to dark as well down here, and I want to hide other objects. Let's just turn let's just make it so this is just so I can kind of see where this is in this view. But another thing I'm noticing is my aspect ratio is off. It doesn't really bring in a resolution on the camera by default from Cinema. So I'm going to just go navigate into my Alembic and find my camera and go to the view and set this to from the drop down to 1080. So now it's like more true widescreen like we were working with here. So let's go back up to the emitter, and I'm going to just grab this sphere, and let's just move it up so that it's sort of taking up, occupying a nice space on our first frame for our sim. So right here, it's a little bit low. I want to just bring it up so it's right up in kind of this upper heel, lower ankle area, just a little bit more well composed inside of this frame, just kind of lining up on the third like that. But the issue is that now if I kind of were to jump out here, and you can see that it's actually intersecting with our shoe geo a little bit. So I'm going to just make some mods on the shoe geo to kind of fill in the top of this heel area a little bit better. So I'm just going to close this. I'm just collapsing it down actually by hitting this down arrow. I'm going to hit spacebar 1 to go back into this view. And then what I want to do is pull out these vertexes just to encapsulate this area a little bit better. So I'm going to go into the actual shoe animation here. And right after the convert, before the shoe, I'm going to insert some stuff. I'm going to do some stuff. So I'm going to select the convert. And what I'm going to do is let's just grab, I'm going to use my selection tool here. The selection tool, by if it's not select to select points or primitives or whatever, you just want to select points up here. And then I'm going to select the visible only button. That basically means that if I make a selection here, it's not going to select any of the verts behind it. So that's good. And yeah, so we'll go with something like this. And what I want to do is just kind of pull this out so that it is not so that it is no longer intersecting with that collider. So let's hit tab with the mouse over the viewport. Hit tab, say soft transform, and it throws down a soft transform node there for us. And I can start pulling those points out, but you can see that the soft transform fall off is so big that it's grabbing the entire shoe. So I'm just gonna dial this down. It's running a little bit slow on my machine, so let's maybe crank this to 0.1. See what it does there. Yeah, that's bringing way too much of the shoe. Let's bring it down to 0.01. And there you can see that it's actually smaller radius, but this is that soft fall off radius that we're working with. I'm just gonna kind of dial this up to be a little bit more. So now we're really kind of filling in more of that that area where the emitter was. Let's just say show all objects. We can see the emitter is still kind of popping through a little bit right here. So what I might do is just pull this out a little bit more until it kind of grabs all of that emitter and keeps it in there. Keeps it enclosed inside the shoe. And you could finesse this as much as you want. I think maybe also increasing the radius to maybe 0.03 might help make that a little bit larger. And then it's looking a little bit, it's not looking super smooth here. So what I might do is also throw it on a smooth. And I'm just going to hide other objects, and this smooth operation, I'm going to turn the filter quality down a little bit. And you can see like it isn't modifying the general shape of our shoe too bad if I kind of toggle this on and off. I mean, we're getting a little bit of modification up here around the edge, but I'm really not concerned with that since we're only kind of doing a general shape here. But it looks like this shoe geo now will fully enclose our actual emitter. So if I look here and show the wireframe, you can see the emitter's in there and it's fully enclosed. It's kind of hard to see, but its outline is just in there. So going back to our camera view and hitting the W key, you can see our shoe looks, for the most part, it looks the same. But yeah, I mean, it has our emitter sort of enclosed. And if I go over to the emitter section and say hide other objects, and you can really see that this is aligned in a much more compositionally good way for our shot. The only other problem with maybe doing some modifications like this, where we've got our conversion and then a soft transform and everything on an animated alembic, is that it's just going to take a while to compute. You can see that here, if I go back to I'll just go to the home view by hitting spacebar H. Our shoe animation is kind of sluggish right now. So what I'll do is just cache this out, these changes. So right after the smooth, I'll throw down another file cache. And I'm going to name this one shoe animation cache. And I'm going to set up the directory structure that I normally like to use. So that would be a cache folder. Then I name it after the operator, so $OS. So that's going to be shoe animation cache, which is written down here. So $OS / hip name, and then / hip name, ... So that will actually create a directory for us that does, all of this. It makes a cache folder, makes a cache folder based off of this, and versions it based off of the file name, etc. So with that, I'm going to I'm just going to cache this out real quick. So here, and click save to disk. All right, now that file cache is done, I'm going to click load from disk, and if I scrub this, you can see it is much more, plays back basically in real time, probably plays back much faster. And if I have the emitter kind of highlighted here, and let's say show all objects, but I'm going to turn off the auto dop network. Okay, cool. So the auto dop isn't visible, but pyro import is. So I'm actually, because the pyro import comes after the auto dop network, I just like to kind of put it down at the bottom here so that it follows order of operations sort of in our scene. But I'm going to disable it because it's by default trying to sim and import these pyro fields. So I don't want to see that, but I want to see the emitter and our collider at the same time to make sure that the emitter is remaining inside of the shoe. So if I do that, it's all staying together, looking good. Cool. So let's just check and see what that's looking like in terms of our sim. Now I'm going to go and turn off these two and hop inside the AutoDop network. Let's grab our camera and just fire off this sim once more. Looking pretty cool. It's filling down to the toe and looking great. With that, with the new position of it, I really like how it just sort of springs into existence right there on the third, and then continues to sort of increase and fill the shoe all the way down to the end. At the end there. So now what we got to do is let's just up-res this sim. I'm not actually going to do an up-res sim, but I'm going to just increase the initial resolution of this sim and then cache this out. So I'm going to do a value of 450. I thought that worked out pretty good for me. So let's just play back a few frames at 450 and see what we get. This is going to go much slower. Cool. So I'm just going to stop it right here around frame 26. And I just want to, because I know what I want to do is actually mesh this thing later. Before I go and fully cache out this sim, I just want to do a little bit of experimentation with what we can do in terms of developing this look later on. So I'm going to hop over to the Pyro import. This is the area where we were going to be importing our fields from the sim and then doing extra work on them like caching, etc. So if we look at our import Pyro fields and we got our import Pyro visualization, the Pyro visualization is just getting that visualization we're using in our Pyro sim from that. If we go over here and into the AutoDop network and on the Pyro object, this multi-field, this is basically importing that visualization that's coming from our Pyro object, whereas this is actually importing the actual fields themselves. So if we scroll down here, you can see that it's grabbing density, velocity, a couple rest fields, temperature, heat, fuel, and color. We're not actually going to use, what I want to use is temperature to kind of adjust our shader. I want to use density to determine what our surface is, because I want to actually create a surface out of this smoke so that it looks like a nice, cool, abstract kind of a growth effect instead of actual smoke. But we don't actually need anything other than density or temperature to do that. But I do at some point want to also use this velocity field to advect particles to add a secondary effect on top of this. So what I'm going to have to do is also keep velocity. But what I've got is I've got my density, I've got temperature. I can just, if I don't, any field I don't need, I can just untick these. So let's just untick the two rest fields. Scroll down, and I'm going to untick the heat, fuel, and color fields as well. So with those gone, I could actually throw it on a Pyro cache here. Oops, a file cache rather. And I'll name this Pyro cache. Wire this in here, and then what I might do is hop over to the shoe animation and just copy this string that I used here, hip $cache $os, etc., and copy that and paste it here. And because this is named something different, it'll create a Pyro cache folder in there and keep everything nice and organized for us. And all we have to do is just copy this one general string, and it'll do that for us. So I'm going to cache this out, and I want to so this is the file cache that I'll run when I'm done, but I'm gonna actually just sort of bypass it for right now. So as long as I don't have load from disk happening, it's just gonna ignore this file cache for right now. And I want to see what I can get in terms of turning this into a surface, just to see if I can get a good shape out of it with the settings that I currently have. So to create a surface, I'm gonna want to split, and I'm gonna actually split off the density. Now that I have density split off, you can't really tell what's going on here because it's it more or less doesn't really, it doesn't represent it perfectly without the visualizer, but I'm going to throw it on a convert VDB. And basically, oops, wire it into that second input here. This convert VDB is going to allow me to convert this volume into a VDB and change the class from fog into SDF. And that actually creates that kind of surface SDF geometry for us. And if I bring this fog ISO value down, you'll see that these bulby structures become more and more defined and looking more like sort of like a coral growth or brain kind of brainy looking. So maybe I'll bring this down to 0.05. You can see we get some really nice blobby, gutsy looks like that. And then I'm going to want to do a convert VDB. So we just used a convert VDB to bring our fog into an SDF. We're going to use it again to convert it back into polygons. So convert to polygons. You can see that it looks pretty jagged in some areas. So I might just smooth this a little bit in between. So let's throw on a VDB smooth SDF. And I'm going to put that right here and highlight it. And you can see it already looks much smoother if we go from before and after. Looking smooth, and I'll just leave that at the default settings and check out what the mesh looks like in the end. And we're getting something like that, which is looking pretty sweet. Other thing that I want to do here is actually transfer some temperature attributes back onto these vertexes so that we can get like kind of a cool shader that we can build based off of the temperature. So what I want to do over here is our split is split off our density on the left hand side, and on the right hand side you can't really see. You can see right here that it's actually got, if I middle mouse click on this output node, you can see that our temperature and velocity are coming in over here. So what I could do is create a attribute from volume, and this basically allows you to take points coming in on the left hand side, or a surface or a mesh or whatever, and then it's like an attribute transfer. Except what comes in on the right is actually a volume. So if I highlight this, you can see that we're getting these crazy trippy colors, and I think that that's because it's actually selecting the velocity vectors and using those to drive the color of this attribute from volume, and the attribute it's creating is color. We can actually get that to just use temperature if we specify it up here. So I'm just going to say temperature, and you can see that it turns it into sort of a gray value here. And if I pop up my lower view that I had down here, if you don't have one, you could just go up here and say split plane top bottom. I'm just going to throw down my geometry spreadsheet here and just check and see what that range of color is that's being created by our temperature values. So it's grayscale, so it's all the same, but it looks like it ranges from very small numbers, close to 0, up to values of like 0.15, at least at this point. So what I could do is on this mapping tab, I could actually change this input range to be something closer to that, so that we're getting closer to like a normal color range from 0 to 1. So if I bring this input range down to 0.15, for example, now we get truly more contrast in those temperature colors. So we can use this later on when we want to go and do some shading. So we're just basically transferring those attributes onto our geo, and I think that that's going to work pretty good. So for recoloring, I could do a map to vector right here. So if I just turn this on, I could just visualize maybe putting a blue color here, and then a purple color here, and then a pink color over here, and get rid of this white one. It was an accident. And you can see that if I were to kind of dial these around, there's all sorts of kind of cool shading opportunities we could get from messing with our temperature values like this. And we'll have more opportunity to really do this later on, but this is just kind of cool to look at. If I switch on smooth shaded, you can see that it does have some weird banding issues that are occurring when it's transferring that color information or that temperature information back onto the geo. But we could throw down an attribute blur and get that out of there by not choosing to attribute blur the position, but actually attribute blur the color. And see how that gets a little bit softer there? And if I crank that up, it really starts to blur out those aliased areas of that color attribute. So knowing that we have all this, I think that this is going to work out great, and we can just cache out our sim. So if I go over here to the Pyro, you can see that Pyro is set to 450. I have OpenCL on. If you if you have enough VRAM in your card, by all means leave OpenCL on. But if you're getting errors at this point, it would kind of pop up and say OpenCL write error. Would pop up in like a little window down here, and it wouldn't cache properly. You're going to want to just turn OpenCL off. It's a longer wait for your sim, but it's just the way it kind of goes with that. So over here on the Power Cache, I'm just going to hit save disk, and I will be back when it is done caching.